Hi there, welcome to my channel Mandu to Fundu. In this video, I am going to explain the solution for the nested list inverse weight sum problem. Let's look at the problem description. We are given a nested list of integers, and in this list each element is either an integer or it will be another list of integers. So for example, here we have two sublists and then one integer in the outer list. And the depth of number 1 is 2 because it is part of two lists, and the depth of the number 2 is 1 because it is part of only the outer list, and the maximum depth is the largest depth of any integer in that input, which is 2 here. Weight of an integer is maximum depth minus the depth of an integer plus 1. So in this case the depth of 1 is 2, so maximum depth is 2, 2 minus 2 0 plus 1, weight is 1. For number 2 the depth is 1 and the maximum depth is 2, so 2 minus 1 plus 1, which is 2, the weight is 2. We have to multiply each integer with its inverse weight and add all of them and then return. For this input it will be 1 time 1, 1 time 1, 2 times 2, 1 time 1, 1 time 1. We have to add all of them, it will be 8. Let's take this input and see how we can solve this problem. This input list has two elements, one integer and one sublist. And within that there is a two integer elements and one sublist. Root nodes and other intermediate nodes represents the list, and the all the leaf nodes represents the integer items. We can compute the maximum depth by traversing this tree. So the maximum depth of an element in this tree is 3. Simplest solution is to use a two-pass approach, but it's not efficient. So basically we have to scan the input 2 times and then compute the maximum depth in the first scan using recursion, and then compute the weighted sum in the second scan by traversing the tree recursively. Efficient way to solve this problem is by doing level order traversal on the input. We keep track of the unweighted sum of all the integers we have seen so far. After processing each level, we have to add the unweighted sum once to the variable weighted sum. This addition operation is equal to increase the weight of the integer seen so far by 1. Let's look at the flowchart for this solution. Nested list is passed as an input to this procedure, and then we initialize the unweighted sum and weighted sum variables. First we check whether the nested list is empty. If so, we return the weighted sum, as there is no more integer to process. If the list is not empty, then we initialize a next level elements list to capture the elements in the next level. Then we process the individual elements in the current list. If the current element is an integer, then we add it to the unweighted sum. If it is a list, then we add all the elements in that list to the next level elements list. After processing all the elements in the current level through this for loop, we come out of that loop. Then we assign the next level element list to the nested list and then add the unweighted sum. We prepare to process the elements in the next level. Then we add the unweighted sum to the weighted sum variable. The outer loop executes until all the levels are processed. Let's move on to the coding part. We initialize the weighted sum and unweighted sum variables. and then we check whether the input list is empty or not. This checks whether there are elements at that level to be processed. Next level element is initialized here. At the end of this loop, this list will contain all the elements present in the next level. This inner for loop will iterate over all the elements in the current level. If the current element is an integer, then add it to the unweighted sum. Else, add all the elements present in that sublist to the next level elements list. After processing all the elements in the current level, next level elements list is assigned to nested list, so that the next iteration of the outer loop process the elements in the next level. And then we add the unweighted sum to the weighted sum once. After traversing all the levels, we will return the weighted sum back to the caller. I'm going to run this program. Okay, it's accepted. So the value is 8. And 17. Okay, cool. Next, I'm going to submit this program. Okay, cool. It's accepted. Let's do the code walkthrough with sample input. Let's use this nested list for our code walkthrough, and it basically has two elements. One is an integer and the other one is a sublist, and then within that there is one list and two integers. First, the weighted sum and unweighted sum variables are initialized to 0, and we pass the nested list which has two elements. So the outer for loop sees that condition is true, so it gets in. Next level element list is initialized, and then we process those two elements in through the inner for loop. First, it checks whether the current element is an integer. If so, it adds that integer to the unweighted sum. So in this case, unweighted sum becomes 1, and it processes the second element, and it sees that it is a list, so it adds all the elements present in that sublist to the next level elements list. After processing all the elements in the current level, unweighted sum is added to the weighted sum variable, and then the next level elements list is assigned to the nested list. Now the weighted sum becomes 1. The outer loop see a non-empty nested list, so we enter the loop and we initialize the next level element list, and then we process those three elements. So first we see an integer, we add it to the unweighted sum, and then we see a list, so we add all the elements in that list to the next level elements list. So in this case, it is a single element list which contains only 6. Next, it see an integer, so it added that value to unweighted sum, so the unweighted sum becomes 10. After processing the elements in level 2, it adds the unweighted sum to weighted sum, so the weighted sum becomes 11, and then the next level elements list is assigned to the nested list. Since the nested list is non-empty, the inner loop process those elements. So in this case, only one element is present, which is 6, so that gets added to unweighted sum. After exiting the loop, the unweighted sum will be added to the weighted sum. The weighted sum become 27, and then when we come out, there are no outstanding elements, so next element list will be empty. Finally, it returns the weighted sum value 27. Next, we will see the time and space complexity of this solution. Let's use this list for our analysis. So this list has two elements. One is an integer and the other one is a list. So the inner loop execute 2 times. In the next level processing, there are 3 elements. So the inner loop executes 3 times. And the third level, we have only one element. So totally the code in the inner for loop executes 6 times. The input nested list has totally 4 integers and then 2 sublists. If we add them, that is equal to the number of times the inner for loop executes. So the time complexity of this solution is order of n plus m, where n is the total number of integer elements in the input and m is the number of sublists in this input. It is approximately order of n. Next we see the space complexity. So at each level we are processing, we need space for accumulating the next level elements. So when we process at level 1, we need space for 3 elements, and when we process the level 2 elements, we need space for 1 integer. So totally we need space for 4 integers. So the space complexity is order of m, where m is the total number of elements in the sublist. In the worst case, it could be order of n, where n is the total number of elements in the actual input list. This can happen when we have only a single element and that is present in the deepest level possible in that input list, then we will end up order of n. Thanks for watching this video. Have a great day.